Let's work on a correlation problem. So correlation is all about the study of the existence of a linear relationship between two variables. Are they directly proportional, inversely proportional, or do they have nothing to do with each other? We collect the heights measured in inches and weights measured in pounds of 7 people. So we have 7 pairs of data here. It's important. The 60 goes with the 155 and the 75 goes with the 220. All right. Because it's all paired data, we can plot the paired data as points on the xy plane. So let's let our x-axis be the heights and the y-axis be the weights. So we have an individual with a height of 60. In fact, let's go ahead and give ourselves ranges. Let's start at maybe 55 on the heights. So this would be 60, 65, 70, 75, and 80. This is not going to be perfect. It's just going to give us an idea of what the data looks like. And that person, oh, wait a minute. We're just giving ourselves ranges. So let's give ourselves the range on the y-axis, the weights. It seems like I have nothing lower than 140 and nothing greater than 240. So that makes for an even, or for a nice range, 100 inches. Or sorry, y-axis is weights, so 100 pounds. Let's plot some points. This first person has a height of 60 and a weight of 155. So about right there. In fact, I want to give myself some more y values. Let's put 160 there, go up by 20s. Okay. Our next person has a height of 75 and a weight of 220. So 75 and 220 puts us right there. And I'm sure you know how to plot data. So go ahead and pause the video if you want to, and catch up with me after all of the data is plotted. All right. So all of our data is plotted, and it doesn't say this in the problem, but let's go ahead and guess what the correlation might be. Because our data is directly proportional, it's sloped positively. The R value has got to be positive, somewhere between 0 and 1, although it's not a perfect line. Maybe it's close to 0.7. But let's actually find it. The equation for the Pearson correlation coefficient is given to us by n, the number of data pairs, times the sum of the product of x and y, minus the product of the sums of x and y. And then we divide by a square root, which has 2 factors. N times the sum of the x squareds minus the square of the summed x's. And it's the same thing over here, except for y's. We use the other data set. Okay, so the best way to solve these problems, I think, is to give ourselves a table. Let's give ourselves the heights, which are the x's. So we have 60, 75, 68, 70, 63, 69, and 72. We'll give ourselves the y's, which were the weights. And remember, it's important that these are paired data, so don't mix these up. And if I look at this equation here, what else do I need? So we're going to give ourselves sums. I need the sums of the x's, the sums of the y's, but I also need the sums of the x times the y's. And I also need the sums of x squareds and y squareds. All right, so we just need to add up all of these values. In fact, let's go ahead and fill out the table. The x times the y column. 60 times 155 gives us 9,300. 75 times 220 gives us 16,500. And go ahead and do this for all of the values. And the second column squares, what's 60 times 60? All right, after you have all of the values that you need these sums. So let's go down the x's first. 60 plus 75 plus 68, and all the way down the line gives us 477. Okay, so now the hard part is over. We have all of the sums that we need, so we can build this equation for R. All right, in the number of data pairs, 1, 2, 3, 4, 5, 6, 7. We took data from 7 people. And I multiply that by the sums of the x times the y's. So that's why we went through all that trouble making that table. The sums of the x times the y's, we can just read off as 86,503. We need to subtract the sums of the x's, 477, times the sums of the y's, 1261, and we divide by a square root with 2 factors. N is 7 times the sums of the x squareds, 32663, minus the sums of the x squareds. Oh, sorry, no, the square of the summed x's, so 477 squared. And in the second term, we have n again, times the sum of y squareds, 22979, sorry, 22, where's the sum of the y's? 229797, 229797. And we subtract the square of the summed y values, so 1261 squared. Okay. So when the algebra clears the room, let's go through this in steps to make sure that we don't miss an algebra mistake. Your numerator, 7 times 86503, minus the product of 477 times 1261 gives you 4024. And each product in your denominator, the first product is 11,112. And the second product is 18,458. Okay, when you go through this, you have 4024 divided by the square root of 205259296. When we take the square root, so this is where we're making an approximation for the first time, we get about 4,530.485, which is going to give us about 0.888. So we weren't far off with that guess of 0.7. The Pearson correlation coefficient is 0.8, positive because it's directly proportional, and pretty close to 1, so probably some significant correlation.